Many of the industries we have today have been run extractively for the last few centuries, and we're reaching a tipping point in terms of not having sustainable supply to keep producing the products that we eat every day. Seafood in particular is a critical area because we have overfished nearly 90% of the oceans. And so with population growth expected before mid-century, we're going to have a food shortage of seafood unless we can produce additional food from a different source. My name is Mihir Prashad. I'm the founder and CEO of Umami Bioworks. We work on developing a platform for manufacturing of cell-based products. This is the Umami Bioworks office. Here we have several of the applications that we have developed and are developing and showcasing right now. Currently we're working on a range of species, including eel or unagi, bluefin tuna, red snapper, lobster, and prawns. We look for species that are endangered, threatened, or protected, and have high demand and name recognition from consumers, but that can't be easily grown on farms economically. So let me take you over to the lab where our team is working. On this side of the lab is where we do all of our cell culture and our cell analytics. And then here you can see the bioreactors. The simple process broken down is we get a fish from a veterinary approved source and we take a biopsy, and from that tissue sample we isolate the cell type we're looking for, and we put it through a single cell cloning device. So that allows us to separate the cells, which means each of them has their own unique genetic identity. And we go through what we call cell breeding, which means selecting the cells that have the right traits. Then we grow those cells to the point that we can start doing screening for media development with two focuses. One is remove all animal components from the media, and the second is to reduce the cost of the media. And then the last real major step is converting the media formulation and the cell line that have been established into a process that grows in the bioreactors and that scales. Once all of that is done, we can send it out for food safety testing. This is my colleague Ninping, who will tell you a little bit more about our early stage process.
Hi, follow me to my workstation. The culture media is a very enriched broth that contains a lot of macronutrients, micronutrients that the cells may need. Right now I'm seeding the cells, and after which I'll be topping up some of the extracts that we have prepared. So we're doing everything now inside a biosafety cabinet because we don't want bacteria to get in. So now I'm going to add some of the extracts into some wells because we just want to test how well this is doing in combination with other extracts. Okay, so now the plates will be left to incubate for a fixed duration, and after which we'll remove the plates, stain them, and then use the imager to analyze the cell count. Then we'll use our software to optimize the brightness, the contrast, and the exposure so that we are able to see the cells in a clearer way. At the end of the entire process, we'll just have to consolidate the data, and then we will analyze it so that it can help us optimize our media formulation. And then from here, we will pass on the best media formulation that we have to Arijit, who is in our bioprocess team, so they can use this to help him scale up in a bioreactor.
I'm Dr. Ajit Das, the research scientist and also group lead in bioprocess upstream development. In this R&D lab, we grow the cells. Initially, when we get the media, we add up the cells in the spinner flask, and then we have to multiply the cells for like 3 to 4 days, and after multiplying we'll expand the cells to the next higher spinner flask, and after 4 days when the cell has been multiplied we'll be shifting it towards the bioreactor. It's like a continuous process. We'll be harvesting the cells for the differentiation. We'll be getting the various fat and the muscle cells, and that fat cells will be going to the food development team where they will be playing with various prototypes and making the real food.
Our goal is actually selling production capacity as opposed to making finished products, to basically be a technology partner. Our core platform brings together stem cell biology, machine learning, and industrial automation. We anticipate having products launching in 2025 with regulatory approvals in, we hope, at least 2 countries. But right now, we're starting with high-end premium products like eel, where consumers might pay $200 or $225 a kilogram. But over time, we see a clear path to being able to deliver 50 to 70% cost reduction from current prices. It's about creating a narrative that is compelling and understanding why consumers might want it. For some, that might just be no mercury, no microplastics. But for others, it might be a fish that doesn't taste so fishy, but is high omega-3. So we have the opportunity to really find an identity that actually meets an unmet desire that consumers have today.